Here's lesson 13 on arithmetic sequences. Once again, this is the second time we've seen it. Remember, an arithmetic sequence is, now we can use the big words, or words we've been using and learning. It's a discrete linear function. Okay, the terms in an arithmetic sequence increase or decrease by the same constant. We call that constant the common difference. Okay, we usually refer to this as the letter D. We refer to this as the letter D, like that. And remember, discrete linear function. Okay, discrete is a series of points. We're not going to connect them. A linear function is exactly where you have a line and you have a function. So for every input, there is exactly one output. Okay. So let's take a look real quick. Mark starts a bank account with $40. He plans to add $20 to it every week. So let's fill in this table for the amount Mark has saved after N weeks. And just as some random amount of weeks, okay, so after 1 week, he's already put $60 in there because he has $40 when it started, and he put $20 in it at the end of week 1. At the end of week 2, he would have $80. He puts another $20 in. At the end of week 3, he has $100. Again, put another $20 in. So at the end of week 4, he will have $120. At the end of week 5, he will have $140. At the end of week 6, he will have $160. And at the end of week 7, he will have $180. Notice, as these go up by 1 every time, these are going up by 20 every time. Okay, so this is definitely linear. We've talked about this in the past. Okay, there is an average rate of change. Okay, it's $20 a week. So let's take a look here at this graph. So if I graphed 1 week, it was at $60. 2 weeks is at 80. 3 weeks is at 100. You know, all the way up to 7 weeks here. 7 weeks was up here at $180. Okay, so let's see, this is 7 weeks down here. So this graph looks pretty good. It's a good connect. We have all of the points there. We've made a line. It's a linear function. It passes the vertical line test. There's an average rate of change. So what's wrong with the graph of this sequence? Well, the thing that's wrong is that, remember, it's supposed to be discrete. Okay, which means I would not be connecting all of the points. In other words, I need to get rid of that line. Now, this is a discrete linear function. And we must always be careful that if it's supposed to be discrete, we leave it as discrete. Otherwise, again, the reason here is at 1.5 weeks, so right here, we should be right about there. But it doesn't make any sense to have at 1.5 weeks because I'm not putting money in on Wednesdays. I'm not putting money in half a week. I'm only going to put money in every once a week. So every Friday or Saturday, I'm going to put the money in the bank, or Mark's going to put the money in the bank. Okay, so it doesn't make any sense to have any sort of data about midweek, which is why we just have these individual points for the exact time that he goes and puts the money in his bank account. Okay, let's take a look at what else we got. Recursive formulas. Again, this is review. Okay, a recursive formula uses the term before the one you are looking for to find the one that you're looking for. And that's a huge mouthful, but it actually makes a lot of sense. Okay, so to find the 5th term in a sequence, we would need to use the 4th term of the sequence. Okay, and we had this crazy kind of formula and notation here. Okay, and now we're going to just kind of add to it this. It's the same thing, just with the new notation from yesterday. Okay, notice the n is here, the n is here, the n sub 1, the n minus 1, sub n minus 1 is there, and here we have the n minus 1. Okay, so it's the same exact thing, just different notation. It all means the same thing though. Okay, and here we go. D is the common difference, and A sub n or A of n are the terms that you're finding. Okay, so what does it mean? Well, it means if I'm looking for, put any number in for n, the fifth term, if I'm looking for the fifth term, then I would use the A sub n minus 1. So 5 minus 1 is 4. I need the fourth term. In other words, the term before the fifth term, and I add to it the common difference. And that's how I can get to the next term. Same thing over here, A of n minus 1. So whatever n was, say n was 7, n minus 1 is 7 minus 1, which is 6. Again, the sixth term is 1 less than the seventh term. I just use the sixth term and add the common difference, and I get the seventh term. So we need to know the common difference. So let's look down here. Use the recursive formula to find the fifth term in the following sequence. Well, it's quite easy. Let's see, I have 1, 2, 3, 4. So in order to find the fifth term, I need to know the fourth term. Well, I do. It's this right here. Okay, that's A sub 4 or A of 4. Let's try this notation. We'll use them both, actually. I also need to know the common difference. In other words, how am I moving from one to the next? From one to the next. And it looks like 17 to 24, I'm adding 7. And then 24 to 31, again, I'm adding 7. And 31 to 38, I'm adding 7. So the common difference here is 7. So D is 7. So let's see how to do this. If I want to find the fifth term, then I'm looking for A sub 5. And A sub 5 is going to be A sub 5 minus 1, which is 4, plus the common difference, which is 7. Well, I'm looking for A sub 5. I know A sub 4. It's 38. And 38 plus 7 is 45. In other words, the next term, or A sub 5, is 45. Well, does that make sense? If I add 7 to 38, well, yeah, that's all I just did, right? And that's how I'm moving from one to the next. Okay? So let's just try it with the other notation. It's the same thing. So A of n over here, okay, in function notation, this would say I'm looking for A of 5, and that's going to equal A of 5 minus 1 plus D, which is 7 in this case. So A of 5 is going to equal A of 4 plus 7. I know A of 4. A of 4, again, is that 38. So A of 5 equals 38 plus 7. Once again, that is 45. So, in other words, the fifth term is 45. So it doesn't matter which notation you use. I just want you to be familiar with both of them for the Regents exams coming up at the end of the year. I have seen it written both ways. So recursive formula, remember, you always need to use the term before the one it is that you're trying to find. There's also a way to deal with these arithmetic sequences to find a term that's very far out without having all of the terms before it. And it's called an explicit formula. An explicit formula for any arithmetic sequence is a formula that will find any term in the sequence. Okay, we can find any one we want. And to use this type, not yipe, this type of formula, all you need is the first term and the common difference from the sequence. Okay, so let's take a look at these two formulas. So again, all we need is the first term and the common difference. Okay, we also, I guess, we need to know which one we're looking for, otherwise this wouldn't make any sense. We need to at least know what position number is the one we're looking for, I should say. So here we go. So to use this, to find any term we want, all we need was the first term and the common difference. You say, yes, but what is this n minus 1 part? Well, again, it's whatever term we were looking for minus 1. That's all we're going to end up doing there. And again, the same exact notation here is I can find any term in the sequence if I know the first term and the common difference, and again, this part is just whatever the n was here, whatever term it is I'm looking for. So what's the 35th term in the given arithmetic sequence down here? Well, let's see. The first thing I always want to try and do is make sure it's arithmetic by finding a common difference. So how am I moving from one to the next? Well, 13 to 22, that looks like it's plus 9. 22 to 31, again plus 9, again plus, yeah, so this is arithmetic. It's going up by 9 every time, so that's my common difference. So D equals 9. Let me write that down over here. Now let's start to use this. Let's see. So if I want to find the 35th term, okay, so n is going to be 35. So I'm looking for a sub 35. That equals the first term, a sub 1, plus n, so n was 35, 35 minus 1 times d. All right, well, what kind of stuff do I know? I know the first term is 13, so I can substitute that in for a sub 1, and I know d is 9, so I can substitute that in. So a sub 35 equals a sub 1, which is 13, plus 35 minus 1, I'll simplify that a little bit here to 34, times 9. All right, so if I have 30, so simplifying this, a sub 35 equals 13 plus 34 times 9. Let's do a little math over the side here. 34 times 9, that's 36. 9 times 3 is 27, plus 3 is 306. So 306 plus 13 is going to be 319. So the 35th term in this sequence is the number 319. Let's do it again over here with the other notation. Again, all this means is a sub 35, or a of 35 in this case, is a of 1 plus n, so 35, minus 1 times d, which is 9. And again, we know a of 1 is 13, so a of 35 equals 13 plus, again, 35 minus 1 is 34 times 9. And again, 34 times 9 is just that 306. So a of 35 equals 13 plus 306. And voila, once again, we get 319, the same number. So the number in the 35th position, the 35th term of this sequence, is 319. Notice I did not need, notice I did not need the 34th, the 33rd, the 32nd, and every term before this. I could jump all the way out to the 35th term as long as I knew the first term and that common difference. All right, well, that is all for this lesson. Again, this was kind of a review lesson, so just, we'll work on it again in class, and hopefully you remember some of this from last time, and we'll go a lot smoother. All right, we will see you next class.